summation and series. Begin. Now here the first thing that you see is how to write in general the sum of some general terms. If there are some general terms, how will you write its sum? That is given as sum over n un. What is un? Un is un is the general term. So here you can write un is nothing but the general term. Okay, it can be anything, like for example xn, n x to the power n, or x by n, something, anything. Okay, now if you are given un is equal to x plus iy, then how can you write the sum? Sum is nothing but s is equal to sum over n equal n. Okay, n to we don't know what is the limits. Okay, so sum over x plus iy, right? Or here you can write exn to the yn. Each term you are adding. So how can you write like this? Sum over n xn plus I times sum over n yn. This entire term, if you can write it as x plus I times yn, this entire term you can write it as capital Y. So this is how you can write the sum of n terms. Now coming to one example, here s is given as 1x x square x to the power n. So x to the power 3. So this is of the form x to the power n, where the first term is equal to x to the power 0, second term x to the power 1, etc. Then you can write the sum. Sum is nothing but s is equal to sum over n equal to, it starts from n starts from 0 to it goes to infinity times x to the power, or sum of x to the power n. Okay, similarly here you have another example. Oh wait, this is the same example. Okay, remove this x 1, remove this 1. Then let us see, here you have x square x cube. Now this is of the form similar x to the power n, but here there is a difference. What is the difference? Here it starts from x, that is x to the power 1. So you have to write n equal to 1 to infinity. Your 0 has gone, so it starts from 1 to infinity x to the power n. Okay, limits have changed. Now here you have the third case, where you have 1x. Okay, so this is of the form you can write here 1. This is also you can write 1 factorial, right? Sorry, here you can write 0 factorial. This is 1 factorial, 2 factorial, 3 factorial. So 1 divided by 0. So x to the power 0 by 0 factorial plus x to the power 1 by 1 factorial plus x to the power 2 by 2 factorial. It goes on. So this is of the form x to the power n divided by n factorial, right? So what will be the sum? S is equal to sum over n equal to, from where it starts, from 0, so 0 to infinity. 0 factorial equal to 1. Okay, 0 factorial equal to 1. Now coming to arithmetic progression. The terms, how will you write the terms of an arithmetic progression is a, the first term, then the second term would be a plus d, third term would be a plus 2d, and etc. up to the last term will be a plus n minus 1. Last term means nth term would be a plus n minus 1 d. This is not there. A plus n minus 1 d. Okay, so this is the last term. That means nth term would be equal to a plus n minus 1 into d. Now okay, this is the last term. What is the last term? A plus n minus 1 times d, that is equal to we denote it by an or sometimes by tn also. Now sum of n terms, how will you write the sum of n term? Sn is equal to n by 2 times a plus an last term, or another formula is also there, Sn equal to just split, rearrange an. Rearrange means write what is an here. An, you will get n by 2 times, sorry, this is not capital N, this is small n, number of terms, n by 2 times 2a plus n minus 1 into d. Fine. Okay, so from this you need to remember only these things. To geometric progression. Geometric progression, the terms, how will you write the terms? First term will be a, then second term will be ar, third term will be ar square, and it goes on. Now what is the a? A is the first term, and what is the r? R is called the common ratio. Sometimes this r can have two values, either it should be less than 1 or r can be greater than 1. Okay, just remember this, we may use this condition later. Okay, now this arithmetic progression is an infinite series. It's an infinite series, while arithmetic progression is finite. Finite. Arithmetic progression is always a finite series. Now why? Because there must be some end to the arithmetic progression, but here there need not be an end. Okay. Now what is this common ratio? Common ratio is nothing but the nth term divided by n minus 1th term. Okay, this gives the common ratio. Now how will you write the sum of here you don't need the last term, okay, but sum of n terms we require, but you will remove this. Now how will you write the sum? Sum is sum over n equal to 1 to infinity a, which is the first term, r n minus 1. Now this is considered as the last term in the series n. Okay, now Sn is equal to a times 1 minus r to the power n divided by 1 minus r if r is less than 1. This is where you use that condition. Sn will be equal to a times 1 minus r to the power n by 1 minus r, where r is less than 1. Similar is a times r to the power n minus 1 divided by r minus 1 if r is greater than 1. Mode of the value r should be greater than 1. Okay, now there is this is for sum of n terms. If there are infinite terms, then S infinity, that means infinite number of terms, a divided by 1 minus r. This is the formula. All these three formulas must be remembered. Important, we can put it as important. Usually for arithmetic progression you don't consider having a finite number, but these are the answers for the sum of finite terms. If n is finite, you can use these two formula, and this is for infinite terms. Okay, now here we have one problem, 1 plus x square plus x cube. So how we can this is extending up to infinity. Now what is the first term? A is equal to 1, and what is the common ratio? R. Common ratio R equal to x. So immediately we can write S infinity is equal to a divided by 1 minus r. And what is a? A is nothing but the first term, 1 minus x. 1 divided by 1 minus x, that is the S infinity. Now this is for now we have seen this is for x mod x less than 1. Okay, so you can write in this way: sum over n equal to 0 to infinity x to the power n is equal to, x to the power n means the first term would be what? The first term would be here the first term is what? First term is 0, sorry, first term equal to 1. So this is similar to, not similar, it is same as our series. So you can write sum over n equal to 0 to infinity x to the power n equal to 1 divided by 1 minus x. Please remember this. This is very important formula. This we would be using in EMT as well as statistical mechanics. Yes, here is one such examples that we are using in statistical mechanics. Z is equal to sum over n equal to 0 to infinity e to the power minus n times beta e. Beta is nothing but half kbt. Okay, beta e. So how will you write this formula? Is I am just rearranging and writing it in a different way. N equal to 0 to infinity e to the power minus beta e whole to the power n. So this is similar to our previous example, n equal to 0 to infinity e to the power x to the power n. What was the answer we got? 1 divided by 1 minus x. Now here what will be the answer if z is given as this? Now what is this z? Z is nothing but partition function. Partition function. Partition function is defined for group of particles in an energy E. Okay, fine. 1 divided by 1 minus x. So here it will be 1 divided by 1 minus x. What is the x? This is x e to the power minus beta e. Now here you have the second question. Sum over n equal to 0 to infinity e to the power minus beta e. This is same, but what is e? E is given as n plus half h cross omega. Now immediately once you get the question, you start writing sum over n equal to 0 e raised to minus beta. E is nothing but n plus half h cross omega. Right, now bring this together. Sum over n equal to 0 to infinity e to the power minus beta n h cross omega into, instead of plus adding here, I am writing another term, okay, plus half h cross omega times beta. Fine, beta half h cross omega, both terms are included. Now this beta h cross omega is a constant, half beta h cross omega, because n is the only variable here, n equal to 0 to infinity. So bring that outside, e raised to half beta h cross omega sum over n equal to 0 to infinity. This I will write it as e raised to minus beta h cross omega whole to the power n. Fine. Now this entire term is nothing but sum over n equal to 0 to infinity x to the power n, that is equal to 1 divided by 1 minus x. So e to the power okay, one minus sign will be there, this minus, okay, yeah, minus half beta h cross omega into 1 divided by 1 minus x. X is nothing but e raised to minus beta h cross omega. Now can you tell me what is this energy n plus half h cross omega, of which model n plus half h cross omega? Here we have n equal to 1 to infinity. Now let us write what our equation will look like, or summation will look like. E raised to minus beta, what is e? E is equal to h cross omega, so n h cross n equal to 1, so h beta h cross omega, this is our first term, plus e raised to minus 2 beta h cross omega, the next term is n equal to 2, plus e to the power minus 3 beta h cross omega, and it goes on up to infinity, right? Now this is of the form x to the power 1 plus x to the power 2 plus x to the power 3, etc. So here x to the power 0 is missing, 0 is missing, so this is of the form there is no 0 but all other is there. So this is a geometric progression with a x to the power 1, it goes on like that, right? So the first term, what is the first term here? X, so that is x divided by 1 minus x, that is the nothing but s infinity, that is infinite terms. So if you want, you can write in this side n equal to 1 to infinity, 1 to infinity x to the power n is equal to n, sorry, x divided by 1 minus x. Okay. We are going to take the derivative of the equation that we know, that is sum over n equal to 0 to infinity x to the power n. This equation is 1 divided by 1 minus x, because our first term here is n equal to 0, so n becomes 0, so our first term is 1. Fine. Now when you take the derivative of this equation, what you are going to get is sum over n equal to 0 to infinity n x to the power n minus 1, n x to the power n minus 1, that's equal to minus 1 divided by 1 minus x whole square into the derivative of this, that should be the coefficient of x, that is minus 1. Now that also we can write it as 1 divided by 1 minus x whole square. Now what we are going to do is, we are just trying to write, since I cannot put n equal to 0 because this the first term will become 0, so I am writing it in the form of making it 1, sum over n equal to 1 to infinity n x to the power. Now when I changes n 0 to 1, here n I have to add 1, right? So it becomes n, that's equal to any change here, okay, so that's equal to 1 divided by again one mistake is there, divided by wait let's see, I think here we have to make, so sum over n equal to 0 to infinity n x to the power, let us write it as n x to the power n divided by x, n x to the power n divided by x, n x to the power equal to 1 divided by 1 minus x square. I think this equation is fine, correct? Just multiplying by x and dividing by x, it became n x to the power n, and then here. Now this is equal to sum over n equal to 0 to infinity n x to the power n is equal to 1 this x will go to left, so it becomes x divided by 1 minus x whole square. Yeah. Now since we cannot have n equal to 1 starting, we will write it as sum over n equal to 1, n equal to 0, here if you put 0 it will become 0, so it doesn't make any sense. So n equal to 1, instead of 0 you will put n equal to 1, n x to the power n is equal to x divided by 1 minus x whole square. So this is the answer. Sorry for that, forget about this step. So this is given as h naught. Okay, now this is falling from a height, that is initially it was at velocity 0 and it is coming down and it is falling here. Okay, so it has covered h naught distance. So from this as I said, you can write velocity when it reaches the ground will be equal to under root 2g h. This is nothing but from v square minus u square equal to 2g okay, v square minus u square is equal to 2g, instead of it is actually 2as, a is nothing but gravity acceleration 2gh, so u equal to 0, so you can write it as under root 2gh. Here you have to write it h naught indicating v naught, so this will be v naught, this will be v1, v2, v3 etc. Fine. Now what is given is E is given as V1 divided by V naught, which means V1 we know this is 2G H naught, right? Under root 2G H naught divided by under root 2G, sorry, this is H1, this is H naught, that is equal to E, coefficient of restitution. Now root 2G and root 2G get cancelled, so E you can write it as H1 divided by H naught under root, which is equal to E square. I can write it as H1 divided by H naught. Now from here I will get H1, that is equal to E square H naught. That means the height to which this ball goes up is nothing but H1, which is equal to E square H naught. Now can you tell me what will be equal to H2 in terms of H1? It will be equal to E square H1. Here you will get H3, which is equal to E square H2. Any doubt here, anybody? Yeah. Then this is E square H naught. This is E square H1, but again H1 is nothing but E square H naught. So this I can write it as E to the power 4 H naught. This I can write it as E square E to the power 6 H naught. Fine. Now the total distance covered will be, it's an infinite series. So from H, from here to here H naught. Fine. From here to here H1. Again from this point to this point plus H1, plus from here to here H2. Again the same distance will cover, plus H2, plus H3, again plus H3, goes on. Now that is equal to H naught plus 2H1 plus 2H2 plus etc. Now we know H naught as yes.
Can you explain how you write this H naught plus H1 plus H1 plus H2 plus H2? I didn't get that.
See here, ball is traveling from here to here, that is your first H1. Okay, this ball will travel from this up to this height, that is H2. Again ball will come down, it will retrace the same path, so that is H2. But the next time ball will not reach the H2, it will reach H3, but it will again come down, which is H3. Again it will go up, which is H4. Again the same distance will come down, then it goes on. So from here H1 it traces first one time, but H2 it will travel twice because it is going up to here and coming back. In the beginning it was not going
yes,
up.
sir, got it, sir.
Yeah. So our equation is H naught plus 2H1 plus 2H2. This is why I said in the beginning, fall with the ball. That's how your CSIR questions will be. That goes on. Okay. Now in terms of E, we will write it as H naught plus 2 times E square H naught plus 2 times E to the power 4 H naught plus again here it is 2 times E to the power 6 H naught, and it goes on, right? So in general you can write Hn is equal to E to the power n H naught 2n, E to the power 2n H naught. Yeah. So the sum, this is the sum. We are asked to find out the total distance sum. Okay, so I am taking this h naught plus 2e square h naught as 2e square h naught as the common 2e square h naught. Then what I will do, just add other things. This will be power, this is e power, this is square 4 4, then e to the power 6, it goes on, right? Yeah, now here you consider what you want. This is first term, second term, third, fourth, so it goes on like this, e to the power 2n, right? That means your first term a is equal to 1 and r, the common ratio is e square. Then how will you write the sum? Sum is nothing but 1 divided by 1 minus r, because your first term is 1. So that you can write it as h naught plus 2e square h naught into 1 divided by 1 minus e square. Again, what you can do here is, you can take h naught as common, 1 plus 2e square divided by 1 minus e square you can do. This will be h naught into 1 minus e square, here you write, plus 2e square divided by 1 minus e square. Now what you can do is just the last step, 1 minus e square, and so this will be 1 plus e square divided by 1 minus e square. This is the total distance.